Okay, good afternoon, student. Am I audible? Okay, thank you. Thank you. So first, I briefly recapitulate what we have discussed yesterday. Thank you very much. Uh, okay, so yesterday we have seen the concept how actually your program executed. So we have started our explanation with one example. What kind of example we have taken yesterday? The example of calculator. So calculator is nothing but we are programming in hardware. So there is a programming which is embedded in the hardware, right? But that calculator is very inflexible, right? You can uh, execute only the different function that is embedded in the hardware, right? You cannot add a new functionality in a calculator. You can use a functionality which is already implemented in hardware, right? So that is inflexible. And suppose if you want to add a new functionality, what you have to do? Again, you have to add a new, implement a new functionality, and again you need to embed the same functionality in hardware. So whenever actually how the hardware will provide you a different types of functionality, for example, you are doing addition. So for the addition, you generate one control signal. So in today's session, you will come to know how the unique control signal will be generated. You will come to know in our example. So in calculator, you provide a data like 5 plus 4, and you will get the result that is a 9. So if you add a new functionality with the hardware, that is instruction interpreter. So in instruction interpreter, now you can provide instruction code as well as a data. So you could see here, there is a two types of input, instruction code and instruction data. And here you can add a new functionality in the hardware. Even you can, for each instruction, the new control signal will be generated. So it is similarly, you have seen this kind of thing is nothing but our computer, in which the programming in software and earlier the programming in hardware. So this is the difference. Now here you can provide a different types of instruction. So the program means it is a sequence of steps, and each steps there is an arithmetic or logical operation we can perform, and for each operation a different set of control signal generated. For addition, a different control signal generated. For multiplication, a different control signal generated. So we have seen mainly there are three components. Like one is a CPU, second one is your input-output unit, and third one is main memory. Similarly, these three components you could see here. That is our one Neumann machine, a very first computer that how this way it has designed. The simple way to understand, we can categorize into only three categories, that is CPU, main memory, and input-output module. So yesterday we have seen the PC, that is program counter, hold the instruction that instruction want to execute. That instruction loaded into the MAR, and PC are incremented by 1, or as per the instruction. If there is a jump instruction, it will be incremented as per the instruction. So the instruction loaded into the MAR. Sorry, the instruction address loaded into the MAR. So PC holding the address of instruction and the same address loaded into the MAR, and then system generate a read signal to read address, instruction address from the MAR. So after generating read signal, this address read from the MAR register and a particular instruction taken from the main memory. So from here, for example, here at number 3, the instruction taken from main memory, and it will be loaded into the MBR. And MBR, then the same instruction transferred into the IR for the execution. Okay, so this IR, so whatever instruction is in the IR, it will be executed in execution unit. So then it will loaded into the execution unit. Execution unit execute the instruction, and the result will be loaded into the MBR. And from the MBR, again, your result will be stored into the main memory. The same, similarly, you can provide your data through the input-output module, right? You might have used in a C programming, you have used a file, you are reading a file, and file is stored into your main memory. And in most of the time, you provide input to your program through the keyboard, that is input module, that is a keyboard, right? So mainly in the computer, whenever the basic function of computer is execution of program. And while actually the instruction is processing, it consists of 2 steps, like one is fetching an instruction and the second one is executing the instruction. And these 2 steps is called instruction cycle. So this thing also we have discussed yesterday. So in a fetch cycle, we have seen how the PC incremented and how the instruction loaded into the IR, and then the instruction interpreted into the ALU, and then it is executed and the result stored into the memory. So in execution, your data move in between processor to memory, processor to input output, data processing and control. So in execution cycle, these different things, the registers. So these different registers, so we have discussed yesterday. Okay. So I hope all you understood up to here, whatever we have discussed yesterday. Now this is the most important thing. You should understand this concept so that you can easily understand whatever we have discussed till today's lecture. Okay, so listen carefully. After my explanation, I will ask amongst you to explain the same diagram because it is very important. Once you understood this, you can easily understand unit number 1. So this is a very important diagram. So listen carefully. After the completion of the explanation of this diagram, I will ask you to explain the same. I will unmute a particular your mic and you will have to explain. Okay. So recall the same concept that we have discussed yesterday, and I recapitulate again today. So look the first box here. Now look at the first box. You look at the arrow, which is here. I think this arrow is visible to you. Answer me through the chat box. The arrow is visible to you, everyone? The arrow movement? Okay, good. Thank you. So observe this arrow. Now this is our memory, and these are the CPU registers. So in memory, there's a 300, 301, 302, 940, 941. These are nothing but the addresses. And we have seen your memory is divided into units. In our example, here is the main memory. There are instruction as well as data. So similarly, here we can visualize the same main memory there, in which there are instruction as well as the data. So here you could see these are the instruction and this data here. So these are the instruction and this is the data. Okay. And these are the different registers are there. PC. PC is what? Program counter. AC is what? Accumulator. And IR is what? Instruction register. So PC. What is a PC? PC hold address of an instruction that you want to execute. For example, there is a 1, 2, 3, 4 instruction. One is executed. Now, which instruction will be executing? Instruction number 2. So PC holder 2. So after 2, PC holder 3. So this is the role of PC. Program counter. And why the counter? Because always it incremented by 1. If there is no any kind of special instruction like jump like that. AC. AC is what? That is an accumulator. Accumulator is one kind of which is a general purpose register on the processor for the operation. So that we call it as accumulator. The very close to your processor so that fast operation will be performed. So accumulator is one general purpose register which is used to store operand. What is operand? Operand means, suppose if you are doing addition of A and B, okay, add A and B, or you in C you are writing C is equals to A plus B. So C, A, B, all these three variables are operand. And what is the opcode? Add. Add is the opcode, and A, B, C is the operand. So what is the role of AC? AC hold the value of operand. IR, instruction register. Instruction register load the instruction. In IR, we load the particular instruction. Okay. So I hope all you understood all these parts. This is the main memory, and these are the instruction. This is the data. PC, program counter, who hold the instruction that you want to execute. Accumulator, who hold the operand. And IR is nothing but the instruction register, who hold the instruction that the instruction is going to execute. Immediate instruction that will going to execute. Okay, now we'll see. Now here, now understood properly so that you can explain. PC holding address of 300. So in main memory, where is the address of 300? Here is a 300, right? So PC is holding address of 300. So here is, this is the instruction, that is 1940. Okay. So in the first step, he holding address of main memory, and this particular instruction loaded into the IR for the execution. Okay. So holding address of 300, and then 300 is the instruction 1940 that will be loaded into the IR. Okay. Now second step. In step number 2. In IR, actually, we interpret the instruction. We understand the instruction. What is the instruction? So as I told you, a unique code signal generated. So for here, the unique code 1. 1 means a transfer data in accumulator. So already I told you, for the computer can understand only 0 and 1, right? So again, for the different instruction, there is a different types of code. Here in considered, 1 is for to transfer the data in accumulator. So this instruction executed. So after execution, they come to know we have to transfer a data into accumulator. But which data? A data which is screen visible to everyone. Now check. Now it is visible. Okay. Okay. So as we are discussing, transfer data into accumulator. So the meaning of this instruction. So one means to transfer data into the accumulator, but which data? A data which is at the location of 940. So what is the location 940? This is the location, that is 940. So in second step, this data will be loaded into the accumulator. Very simple. Okay. So 940. So at the 940, this is the data which will be loaded into the accumulator. So as soon as the instruction 300 executed, PC incremented by 1. So as we have discussed earlier. So this instruction executed and this data loaded into the accumulator. Now instruction executed. Here the PC incremented by 1. Now the address is 301. So here in the main memory at the 301 there is another instruction, that is 5941. So in the next step here you could see 5941 loaded into the IR, instruction register. Now instruction register, again this instruction will be executed into the ALU. So IR decode the instruction. So what is the meaning of 5? So 5 meaning is addition. 5 is for addition. So addition with whom? Which kind of data? So data which is given in the instruction, that is 941. Data which is at the location of 941. So at 941, what is the data? 0002. So the addition will happen in between accumulator and a data which is at the location of 941. So here you could see here the accumulator holding a value 3. And at 941, what is the value? That is a 2. So 3 plus 2, that is 5. So accumulator update its value after the addition. 3 plus 2, that is 5. Here you could see accumulator value is a 3 and 941 is a 2. So 3 plus 2 after addition, because 5 meaning is add. So after addition, the value updated as a 5. Okay. Now here in the next step, what is the next step? So after the execution of this 301, as soon as 301 executed, addition have complete addition done here. So the PC incremented by 1 and now the PC became 302. So instruction at the address of 302 will be loaded into the IR, that is instruction register. So 2941, this instruction loaded into the IR. Now IR again decode the instruction. What is the meaning of 2? The 2 meaning is accumulator result back to memory. Accumulator result stored into the main memory. But at which location? A location is given here, that is 941. So at 941, whatever the result, you have the accumulator holding that result will be stored into the location number 941. So in the last step, you could see here, this 0005, this accumulator result will be loaded at the location of 941 IR. Okay, so it's very simple how actually your instruction executing. Okay, so I want to ask you, who will going to explain? Okay, so here I think you could see the random number generator. Yes, now you can see the random number generator. Okay, तो जिसका भी number आएगा, here is this 10 at this location. Whenever I will click here, I will get a number in between 134 to 173. तो जिसका भी number आएगा यहाँ पर, उसे explain करना होगा the same example. Okay, because even yesterday I told you, you have to explain because it's an important thing. Okay, so generate. Okay, 163. So participants. Rajesh. Rajesh. Rajesh, explain the same example. Rajesh, are you there? You can unmute yourself. Rajesh, turn on your video. Okay. I will generate another number. 173. Okay, 173. Deepak Patil. Deepak Patil, unmute yourself and explain the same example. Deepak Patil, are you there? See, otherwise I might abstain to all of you. If you are unable to explain, tell me. No problem. Again, I will explain the same example to you. Deepak Patil, okay, absent? Another 157. Mansi Pawar.
Yes, sir.
Unmute yourself.
Yes, sir.
Good. You have shown confidence. Otherwise, the boys have too much fear to explain this simple. Beta, can you explain this briefly? Hello?
Okay, I will try. Hello.
Yeah. You continue. Even you can explain in Hindi, no problem, huh?
हाँ सर. Sir, I don't know how to start.
Okay. So answer my question. Do you know what is PC? PC क्या
Yes
करता है तुम्हें
sir.
पता है?
हाँ, होल्ड करता
क्या
है,
करता
जो
है?
एग्जीक्यूट करना है उसको, उस वैल्यू को
जिस इंस्ट्रक्शन को एग्जीक्यूट करना है
होल्ड कर,
उसका एड्रेस वो
उसको
होल्ड करता
होल्ड.
है, राइट?
हाँ हाँ.
हाँ. तो यहाँ पे कौन सी क्या नंबर होल्ड किया है उसने? 300, राइट?
300. हाँ
300
तो
एड्रेस होल्ड किया है ना?
हाँ,
तो
तो
ये जो
उसकी
एड्रेस
वैल्यू.
है ये मेन मेमोरी में कहाँ पर है? यहाँ पर है.
हाँ
तो ये जो 1940 है, राइट, ये इंस्ट्रक्शन एग्जीक्यूट होंगी, राइट? तो
हाँ.
आईआर क्या करता है? आईआर आईआर की जरूरत क्या है?
इंस्ट्रक्शन रजिस्टर.
इंस्ट्रक्शन रजिस्टर की जरूरत क्या है? हाँ, तो उसके पर्पस क्या है?
वो एग्जीक्यूट करता है. सर, लीड इंस्ट्रक्शंस को लीड करता है.
हाँ. आईआर नहीं, आईआर
लोड
जो
लोड करता है
इंस्ट्रक्शन अभी
पर्टिकुलर
एग्जीक्यूट होने
इंस्ट्रक्शन.
वाले एक्यूमुलेटर में.
हाँ
देखो, ये हमने सेम डायग्राम हमने देखी थी इधर. यहाँ पे देखो, जो ये आईआर में जो भी इंस्ट्रक्शन होंगी वो एग्जीक्यूशन यूनिट में एग्जीक्यूट होंगी,
हाँ
ठीक है ना? जो भी
हाँ
आईआर के अंदर इंस्ट्रक्शन लोड होंगी वो एएलयू, ये है नीचे एएलयू, जो
सर.
अरिथमेटिक लॉजिक यूनिट, इसमें इस एग्जीक्यूशन यूनिट में वो लोड होंगी, ये एग्जीक्यूट होंगी, राइट? तो फिर आप
हाँ
उस इंस्ट्रक्शन को लोड करने के बाद में एग्जीक्यूशन यूनिट डिकोड करेगा उस इंस्ट्रक्शन को और उसे फिर एग्जीक्यूट करेगा, राइट?
राइट.
तो ये यहाँ पर एग्जीक्यूशन यूनिट में जाने जो इंस्ट्रक्शन जाना है वो पहले आईआर में जाएंगे, इसलिए वो आईआर है, ठीक है? तो इसी तरीके से अभी इस इंस्ट्रक्शन को एग्जीक्यूट होना है 15940. ओके. तो इसलिए आईआर में जो इंस्ट्रक्शन अभी ऐड की गई, वन का मीनिंग था ट्रांसफर डेटा इन एक्यूमुलेटर. तो 940, अभी हम
हाँ
940 को देखेंगे, इस एड्रेस को. 940 इस एड्रेस पे जो डेटा है 0003, उसे एक्यूमुलेटर के अंदर लोड किया जाएगा. ये लोड हो गया यहाँ पर.
हाँ
अभी पीसी क्या करता है? पीसी जैसे ही वो इंस्ट्रक्शन एग्जीक्यूट हो जाती है, पीसी एक से इंक्रीमेंट होता है. इसलिए पहले क्या था? 300 था, यहाँ पर एक से इंक्रीमेंट हुआ, 301 हो गया.
301.
क्लियर हुआ यहाँ पर? यहाँ तक clear?
हाँ हाँ सर.
Hello? Hello? Hello, am I
Yes,
audible?
sir. Yes, sir.
Mm-hmm. Okay. So at accumulator, this data loaded, then the PC incremented by 1301. So at 301 is another instruction, that is 5941. So this instruction will be loaded into the IR. Okay. Now you continue from this point. अभी यहाँ सब बताओ क्या हो रहा है, इंस्ट्रक्शन को लोड किया गया IR में, अभी क्या होगा?
5 का मीनिंग होता है ऐड, तो एसी की वैल्यू और 941 की वैल्यू ऐड होगी.
राइट. और उसके बाद
एसी में वो वैल्यू, देन स्टेप 4 में एसी में वो वैल्यू जाएगी 0005 और
राइट. उसके बाद क्या हो रहा है नेक्स्ट स्टेप में, स्टेप 5 में?
हाँ, स्टेप 5 में वो पीसी में 1 से इंक्रीमेंट हो जाएगा, तो वो 302 होगा. फिर उसकी वैल्यू जाएगी आईआर में. फिर 2 का मीनिंग होता है एसी रिजल्ट बैक टू मेमोरी. फिर एसी में जो रिजल्ट है 0005 वो 941 की जगह जाएगा, मेमोरी में बैक आ जाएगा.
राइट. राइट. थैंक यू वेरी मच.
थैंक यू सर.
ओके, now you can mute yourself.
Okay.
Okay. So it is very simple actually. You should try to speak. Otherwise, because after all, after 1 or 2 years, second year and third year, you have only 2 years you have, and you might know about me. I am a TNP coordinator of computer department, right? So when you will be in the final year, maximum time you will communicate with me only, and it is a very important thing. You should be able to express yourself. You should be able to answer, because after all your final selection would be based on how you are answering, right? So now you might have thinking only to finish your engineering, but this is not the goal. Your parents, the society is expecting output from the engineering, right? Why you are doing engineering? To get a benefit, na? Either you want to become an entrepreneur, or you at least you want a good job, right? But when you will get a job, or even if you want to become an entrepreneur, you have to speak. And until and unless you are not showing a confidence to answer, it would be very difficult for you to getting place in any company. And it is not the case within 1 month you will be expert. You will have to try from the second year. You will have to answer. Okay. And I was damn sure, because first two boys na, मुझे पता था कि वो अनम्यूट नहीं करेंगे. As soon as the next one, the number is for the girl. So she tried, and finally, very well, she explained the remaining steps. तो आपको कोशिश तो करनी ही होगी. हमेशा कब तक भागोगे आप? नेक्स्ट लेक्चर में फिर से मैं पूछूंगा, उस वक्त क्या करोगे? हमेशा म्यूट ही रखोगे? तो आपको ये कोशिश करनी है कि आपको आंसर देना है, और फाइनली आपका सिलेक्शन उसी के बेसिस पे होगा, और वो एक दिन में नहीं होता है. ओके. I hope you will take these things positively. So mainly, what are the different operating steps? The same thing again I'm discussing here. Why actually I have given more time on this diagram, because whatever the different topic we will discuss in unit number 1, all the topics are related to this example. That's why actually I have given time to understand this example. Because once you understood how this simple instruction is executing, what is PC, what is the role of PC, what is the role of IR, what is the role of AC accumulator, you can easily understand unit number 1. You no need to take more efforts. So this is a part of understanding. So operating steps. So if you will see the operating steps, already we have discussed these things. Just again, it is only one kind of revision. Like your programs reside in a memory through the input devices. How actually your program store into the main memory? Through the input device, right? In C, you have implemented a different program. So how the program you can store into the memory through the input device, through the keyboard. First, you have to type your program, and then you can save your program into the memory. So PC is a set to a point to the first instruction. So program counter, right? So we have seen program counter. He hold the address of first instruction. So PC holding an address of first instruction. Then, so in our example, we have not considered MAR and MBR, or if you are referring another book, you will find instead of MBR, it is MDR, memory data register. And in William Sterling, it is MBR, memory buffer register, but both are same. So we have not considered this MAR, MBR, but their role is very simple. So PC holding a first instruction. So the contents of PC are transferred to the MAR, memory address register. So PC is holding a first instruction, and then PC transfer his address to the MAR. And then PC incremented by 1, or as per the instruction, the PC set a value. MAR, what is the meaning of MAR? MAR is a memory address register. So PC में क्या था? Address था. तो MAR, memory address register, क्या hold कर रहा है? Address. किसका? Memory का. Right, so it is a register. So again he hold address. Right, MAR holding a address of instruction. Then a read signal sent to a memory. Then whatever the address MAR holding, for that particular address, a read signal generated for the memory, because we have to read the instruction from the address, whatever the address MAR holding, the same instruction we have to read from the memory. That's why the read signal generated. So the first instruction is read out and loaded into the MBR. MBR is what? Memory buffer register. So the MAR is holding the address, but the MBR is holding an instruction, right? The difference between MAR and MBR. So that instruction, whatever the instruction read from the main memory, it will be loaded into the MBR. Now it is transferred into the MBR, and then the instruction will be transfer from MBR to the IR, instruction register. So MAR, MBR, we have not taken an example, but the role is same. PC sending instruction address to the MAR, and instruction loaded into the MBR, and after MBR, the instruction loaded into the IR, instruction register. The contents of MBR are transferred to IR. So here, whatever the contents, like we have seen, for addition, a different operand required, that also transferred to the IR. So instruction first decode and execute the instruction. Instruction decoded. We have seen how the instruction decoded. 1, what is the meaning of 1? What is the meaning of 5? So instruction decoded, and then instruction executed. Now the question is how they will get the operand. So for the operand, for example, if you are doing addition, so A plus B, so A and B is nothing but the operand. And what is the instruction? Plus addition is the instruction, and A and B is the operand. So how these operand get to the ALU, arithmetic logic unit? So the same way. So MAR holding an address of operand, like an instruction we have seen in the example. In the instruction, there is an address of data. 1941, for example. So at 941, there is a data, and 1 means the load into the accumulator. So what we have to load into the accumulator? Data which is at the location of 941. Right? Similarly, so address to MAR, whatever address is there in the MAR, data read from that particular address and loaded into the MBR, memory buffer register. And from the memory buffer register, the data will provide it to the ALU. In this way, ALU get the operand. Then ALU perform operation on the operand. So for example, the instruction is 5, it means addition. So he get the data in the form of operand through the MBR. So he perform addition. So ALU perform operation. Then the ALU store the result back. So again, there is a general purpose registers are there. We are considering only one register. As I told you, it is a one Neumann machine. At the very beginning, how the computer developed that machine, one Neumann machine. So in which actually we are considering accumulator for the general purpose register. So how the result again store back into the main memory? So again, from the MAR, get the address. Again, we have seen how the instruction provide the address where to load the result. So from the MAR, he get the address where the result should be stored into the main memory. So from the MAR, get the address and the result stored into the MBR at particular location. And during the execution, PC incremented to the next instruction. So while the ALU executing a previous instruction, the PC incremented to the next instruction. So these are the different operating steps in the CPU. Now you can easily understand this instruction cycle. This instruction cycle you can easily understand. If you could understand the example and whatever we discussed in this topic. Okay, so now the first step is instruction address calculation. Here the first step, instruction address calculation. Because PC is holding an address, MAR is also holding an address, right? So first we have to calculate the address. At which location the instruction is there, the first instruction address. So that instruction address calculated at the beginning. So PC and MAR having an instruction address. So here is the address. Then the instruction page. So read signal generated from the memory. So that is instruction page. So in the instruction page, instruction operation decoding. So here instruction page. Instruction page means your instruction loaded into the IR from the MAR. So that is the instruction page. This is the instruction page cycle. In instruction page cycle, your instruction loaded from main memory to the IR. Then instruction operation decoding. Then ALU has to decode the instruction. What is the meaning of instruction? We have seen the example. 1, 5 having a different meaning. 1 is for to load a result into the accumulator. Load data into the instruction into the accumulator, 5 addition. Similarly, we have to decode the instruction. So after decoding instruction, suppose your instruction is A plus B, right? So here, after decoding, the ALU came to know this is for the addition. And to perform this addition, 2 operand required, A and B. So again, the next step is operand address calculation. So the next step is, again, we have to calculate address of operand. operand address. We have to calculate operand address A and B. So there is a two operands are there. So address calculated here, and we have to fetch the operand. So here you could see there is a cycle for two operand. So operand A fetch, and then operand B fetch. So for the multiple operand, here you could see there is a two lines are there. To operand fetch A and operand fetch B for the different addresses. Okay, so operand fetch here. Now here we have the A and B. Now the next step is perform a data operation. So data operation, that is here, that is instruction is for addition. So A and B addition perform here. So addition performed. Now we have to store a result. So to store a result, again we have to store this result into the another operand, that is C is equals to A plus B. So we have a third operand, that is a C. So, but again, to store a third operand C, we have to calculate the address. So next step is operand address calculation. And then we will store the result, the store C into the main memory, right? But here I have taken only a simple one example, addition. Suppose if you are calculating the area of circle, rectangle, triangle, right, different shapes. So multiple result we have to store. So that's why again here you will find there is a cycle for to store a multiple result. So operand store area of circle, area of rectangle, area of triangle, right? So multiple result would be stored here in operand store. So now you might have seen the same result. You might have implemented a program where we use our result for the next operation, right? Again, for the next for any types of calculation. For example, you are calculating house price, in which you are asking how many rooms are there, what is the build-up area, so many things are there. And finally, by considering all the things, you have to calculate the cost, right? So first you are asking how many rooms are there, how many bathrooms are there, and their area, what is the build-up area, what is the parking area. So, and finally you are going to calculate their complete cost. Okay, so here actually you are calculating multiple things, and you are accumulating all these things together to calculate their final price. So similarly here you could see operand, we have to provide this operand to the operand address calculation, return for a string or vector data. And if it is completed, no need to return a result. Then it informed to again the first step, instruction complete, fetch a next instruction. Again, here PC incremented by 1, and next instruction will fetch. So this is a simple instruction cycle state diagram. If you could understand our previous example, you can easily understand this instruction cycle state diagram. So I hope all you understood whatever we have discussed in today's session. So if you understand today's lecture, kindly acknowledge in chat box. If you have any doubt in any topic, kindly tell me. Again, I will explain the same topic for you. We have 7 minutes. Okay, have you understood today's topic? Any doubt? Okay, thank you. I think On Monday, you will get all the material, PDF, as well as the same lectures I am recording on, I am uploading on YouTube also. So even if you want to watch any lecture, you can refer the YouTube channel. So you can search Sachin Pradeshi Sherpur. You will get my channel, in which you will find all the videos I have uploaded over there. So even you can, the videos are there. You can refer this video from there. Okay, thank you. Thank you, everyone. Okay, so our session is over.